Okay. All right, so what mass of silver chloride can be prepared by the reaction of 100 mils of 0.2 molar silver nitrate with calcium 100 mils of 0.15 molar calcium chloride. And actually for this purpose, or for these purposes, I'm just going to put a 1 unidirectional arrow, that way it makes it easy on us. And so this is going to be calcium nitrate, which is going to be 2 of those. So just to balance this, so we're going to need 2 of those, which means we're going to need 2 of those, which means we're going to need 2 of those. And just so that things aren't too squished. And then that looks balanced to me, so that looks good. And so just writing out our volumes or our givens, so 100.0 mils, 0.20 molar, 100.0 mils, 0.15 molar. And so our moles of silver nitrate is just 0.20 moles per liter times our volume, which is 100.0 mils. So this needs to be in liters, so 1 liter per 1,000 mils. And so that our mils will cancel and our liters will cancel, and we get an answer in moles, which is just 0.020 moles. And now if we check our moles of calcium chloride, it's 0.15 moles per liter times 100.0 mils times 1 liter per 1,000 mils, which is just 0.015 moles. Okay, so there's our moles of our species that are present in our solution. Now, if we check our equation, we need 2 moles of AgNO3 per 1 mole of calcium chloride. Or to put it more into the terms of our question, 0.020 moles of silver nitrate will react with 0.010 moles of calcium chloride. Okay, so now we've identified that we have an excess, right? So we're only going to be able to react with 0.010. And so that means that we're going to have 0.005 moles of calcium chloride excess. All right. So that's okay. So the first thing it asks us anyway is what mass of silver chloride we're preparing. And so if we look at our equation again, we have 2 moles of AgNO3 giving us 2 moles of AgCl, right? So for every 2 moles of AgNO3, we get 2 moles of silver chloride, right? So then 0.020 moles of silver nitrate will give us 0.020 moles of silver chloride, right? Although it's a 2 to 2, it essentially is a 1-to-1 ratio, and so after reacting 0.020 moles of silver nitrate, we're going to end up with 0.020 moles of silver chloride. So to get the mass of silver chloride, we're going to need our molar mass, which is just the molar mass for silver plus the molar mass for chlorine, which is 107.87 grams per mole plus 35.45, which comes out to be 143.32 grams per mole. And so then our mass of silver chloride is the molar mass multiplied by the amount of moles, which is our 143.32 times 0.020 moles. So our moles cancel, giving us a value in grams, which comes out to be 2.866 grams, or rounding to 2 significant digits, 2.9 grams. And now the other question it asks is the concentrations of each ion remaining in solution after precipitation is complete. So here, we have initially to consider that we have our silver nitrate. Actually, I guess we might as well just go by our posted products. So our products are calcium nitrate, so we need to consider that. And then the excess calcium chloride. So we know we have excess 0.0 what did I say? 0.005 moles of calcium chloride from excess. And also from looking at our equation, for every 2 moles of silver nitrate, we form a mole of calcium nitrate. So 2 moles of silver nitrate forms 1 mole of calcium nitrate. And so put another way, 0.020 moles of our silver nitrate will form 0.010 moles of our calcium nitrate. All of these will dissolve in solution, so writing them like this is actually kind of pointless. So calcium nitrate is going to dissolve into calcium 2 plus 2 NO3 minus. And so looking at this solution, this equation here, so if we have 0.010 moles of this species, then we're going to get 0.010 moles of calcium 2 plus and 0.020 moles of NO3 minus, because we get double. Okay. And then looking at our calcium chloride, which is going to dissolve into calcium 2 plus 2 Cl minus. We already know we have 0.005 moles excess, so we're going to get 0.005 moles of calcium 2 plus and 0.010 moles of chlorine. Okay, so then the ions we have in solution then are calcium 2+, which the amount of moles from summing these two values is 0.015. Our nitrate is 0.020, and our chlorine is 0.010. Now to get our concentration, we need our volume. We poured in 200 ml solutions, so our volume is 200 mils. And so then our concentration of calcium 2+ is our moles over our volume. And now molar is typically in liters, so we're going to want to multiply 1,000 mils per liter, canceling the mils, and giving us 0. Why didn't I write this down? Oh, right, 200 mils, sorry. 0.075 mils. 0.075 molar. Okay, and then our concentration of NO3- is 0.020 moles over 200 mils times our 1,000 mils per liter, which comes out to be 0.1 molar. And our concentration of chlorine which is the same, or calculated in the same way, I should say. Canceling units everywhere. 0.050 molar. Okay, and so there's our concentration of all our ions left in the solution. Okay, so looking at the solution here, so we identify the number of moles, identify our limiting reagent, and then find the mass of silver chloride by identifying the number of moles and finding the molar mass. So it comes out to be 2.86 grams. So that's about what I got. And then round it to 2 cigs would be 2.9, but that's okay. And then the concentration of our remaining ions, so 0.075 molar, 0.05 molar, and 0.1 molar. So that looks good. So those all look good to me.